So welcome class 10th students in our chemistry class, and we are nearly about the end of our this third chapter, that is acid, bases and salts. And today we are going to deal with the preparation of salts by the process of neutralization. Now in this neutralization we will be studying both when an acid reacts with insoluble base, then how salt is being prepared, and when an acid reacts with a soluble base, that is an alkali, and that process is basically known as titration. And why titration is there in why titration is necessary, what titration signifies? Actually, in that both the reactants and the products, I'm explaining about, I'm just giving some points about titration when an acid reacts with a base, that is soluble base, and we have to prepare the salt. So preparing the salt, all of you know, you have to take the filtrate or whatever. In the case of precipitate, yes, in the case of precipitate, the reaction which are forms precipitate, which forms insoluble salt, there you take the residue and crystallize it, and but in the rest of them you have to take the salt and you take the filtrate. So just try to understand the basic difference. So here I was talking about titration. So titration, since the reactants and the products both are soluble, so therefore if we don't follow this method, process of titration, the solution which we are getting, it may be acidic, it may be basic. Why? Because we don't know how much exact, both are soluble, we don't know how much exact amount of base is there or how much exact amount of acid is there in the solution. So what happens? We have taken a base and we are pouring acid drop by drop. So, and we have added some indicator. I will explain it very thorough in detail also, but I am just giving you the glimpse. Okay. And we get an indication, the color changes, and we get an indication, yes, all the alkali has been neutralized by the acid. So we stop the addition of acid. Now in the solution which we are having, it contains acid plus base, that is, it contains after neutralization it contains the salt. So that's what I was telling, it is neither an acidic, neither an basic. If base will be there, so if acid will be there in more amount, if base will be there more amount, so accordingly it will be acidic salt or basic salt, as we have studied. So that's why the titration is very effective there. Now let us discuss these two processes one by one. First, with an insoluble base, reaction of acid with insoluble base, and just preparing the salt, and then afterward we will go through the titration process. Now you can see before you the preparation of salt with the help of an base and acid, and the base here is insoluble. We have taken copper oxide, which is black in color. You may also take the insoluble base, that is copper hydroxide, CuH whole twice, and you can react it with an acid. Now what is the process? Step 1, you take dilute H2SO4, the acid, and then you take the insoluble base, copper oxide or copper hydroxide. Both ways you can do. So we are dealing with copper oxide, it's given in the book, copper hydroxide also, both are insoluble base, no problem. Now you go on stirring it, you go on making it, and unless and until no more this you go for the saturated solution, in fact. Now then a reaction takes place and it forms copper sulfate. Now what you have to do, you have to filter it. Why do you filter it? You filter it because if some impurities are there, in order to remove those impurities you filter it. Now this filtrate, the clear liquid, it contains copper sulfate, CuSO4 copper sulfate solution. So you got this filtrate. Now you have to make this, or you have to make this go through the process of crystallization. So what will you do? You will take it in a vessel, and a china dish, evaporating dish, whatever you call, you take the filtrate and you start evaporating it, slowly evaporating it. So as soon you will see some crystals are being formed. So you have made a saturated solution. Here you made a saturated solution in fact. So here you make a saturated solution and you observe formation of crystals. Now you allow to form the crystals. You allow it to cool, and during the process of crystallization, this crystals are formed and it takes 5H2O. What is 5H2O? It is the water of crystallization. So dear students, one important thing to be remembered here is that during the process of crystallization, it takes some water molecule that is known as water of crystallization. It is the internal part of the process of crystallization, that during the process while cooling, it takes along with some water of crystallization, and this water of crystallization imparts the crystalline structure or the color to the crystals. Therefore, it is blue in color. It's basically CuSO4 reacts with H2O and it forms CuSO4 5H2O. During the process of crystallization, it is blue in color. When you will heat it, it will change the color. It will again change back to white. So this was the formation of copper sulfate by the process of reacting an acid with an insoluble base. You filter it, you make a saturated solution, and then the process of crystallization. Now we will go for the reaction of an acid with a soluble base, that is alkali. Now formation of salt by the process of reacting soluble base, that is alkali, with an acid, that is, it is known as the process of titration. It is now why this titration is being conducted, and it will be very helpful in your laboratory also. You must know this process of titration. Actually, what happens that you in the initial you have seen that you take initially the acid, just the process which we have discussed with insoluble base, and then you pour base in the insoluble and you stir it till no residue remains, and then after you go and filter it, and then you go for the process of crystallization by the making it a saturated solution. So what is the point here? The reactant as the product, both are soluble. So we don't know what is the basic nature, what is exactly the nature of the solution formed, whether it is an acidic or whether it is an basic. All are soluble. So we want to know the exact amount, what the exact amount of acid is being required, or what the exact amount of, more correctly, what the exact amount of base is being required to neutralize that acid, so that the solution contains perfectly the salt. So that's the process of titration, why it is important to know the end point, how much alkali is being required, or sorry, how much acid is being required to neutralize that particular amount of alkali. So for that we have apparatus. This is a burette. It has all the volume showing in cc. The measuring marks are there. Then we have a glass cork here at the end, right? And this is called burette. Then we have pipette. The pipette it's also a cylindrical one, thin one. It has an opening from both ends. And what we do is, pipette is like that. We suck, and then if you have to take 10 ml, we suck up to 12 ml, 15 ml, and then we just close the upper end, and then we slowly open it and we see whether it has reached its mark. So exact amount of the solution or whatever acid or base is required, we take it through the pipette, right? Now here what we do, first step we have taken acid, filled it up to 0 cc, right? We have filled it, we will measure it. Now through this pipette we suck the alkali, that is the soluble base, and we take suppose known amount. We take known amount of alkali, that is 25 ml of NaOH. So initially what happens, we have in this contains acid or burette, and through pipette we have measured the alkali and we have put it in this conical flask. Now initially this is colorless. Now we add some few drops of the indicator, that is phenolphthalein. So it becomes pink. What becomes pink? The color of this alkali becomes pink. Now we go to step 2. We slowly, drop by drop, we allow this acid to pour in the flask, and this flask is to be repeatedly shaken. So whole of the acid gets mixed immediately. Means the process of stirring is to be done continuously. You stir this conical flask and you allow the acid to go into this alkali drop by drop, and the stirring process is to be done so that complete reaction or dissolution takes place. Now you will observe the color, the pink color changes to colorless. As soon as you will observe the change in color, you have to stop this call. Means this alkali has been completely neutralized by the acid. Now no more acid is required, otherwise it will become an acidic. So you have now the salt what you want to get. So this process of exactly you get the salt. Now the third and fourth process are the same. You can filter it, clear the unwanted residue if any there, and then you evaporate it and you make a saturated solution. You make a saturated solution to get the crystals, and this 10H2O attached to it, that is known as the water of crystallization during the process of crystallization. So, and this is the reaction. So this way salt can be prepared by soluble base. Now dear students, this ends our chapter number 3. Now there is one more topic left, hydrolysis. So I will see, if you wish, I can or I will go through it. I will give the lecture in the next, that is on coming Saturday. And one thing I would like to tell you, that now this topic has been completed. We have gone through it very deeply, and I have tried to explain you all the things. So take maximum benefit of it and prepare it accordingly. Now the fourth chapter, the analytical chemistry, or you can say the 3B. This is 3A, 3B. 3B analytical chemistry is to be done by you. Why? Because it needs a lot of cramming. I will give a lecture over it, that whatever the explanation part is there, I will give it to you, but the whole explanation part has been already covered in this acid, bases and salts, because analytical chemistry is analyzing the cations and the anions present in a given substance, and that is to be done by the color of the ions, right? So we will see there. I will give you one lecture, but start preparing. Why I am saying this? Start preparing analytical chemistry. Start cramming analytical chemistry. A lot of cramming is required, and it is very helpful. Both these chapters 3A and 3B will give you around about 20 to 26 marks question. That's why I have taken so much time. So your duty is also to give that much time in preparing it. So we will finish it. We already have finished, and I will be taking one hydrolysis in the next lecture, and we will finish. And analytical chemistry you have to do you by yourself by cramming, because a lot of cramming is good. Again I am telling you. So that's all for today. Thank you very much.